Yay! All right. So my name's Amir. That's my Twitter handle. That's my website, and that's where the source for this talk is going to be. Okay? So you can clone that. There's actually a sample project in there also. So you should be able to open up Visual Studio and right-click this console application, and it should start up, and you should be coding. Cool? All right. So this is a... Let me start my timer. This is a true story, or it's based on a true story. I was actually at a client back in 2010, and I was brought on to do a new website, an MVC application, and on top of that, I was also required to work on WinForms, a WinForms app, and I was also required to make sure that that new MVC application worked on IE8. So great project, if you can tell. Right? It was 2010. I mean, back then, IE8 was a thing. That's terrifying to say. 2010, IE8 was a thing. All right, so here is a sequence diagram written completely in ASCII. Isn't that beautiful? And this was a real problem that I had to deal with on this MVC application. So we had IE8. Some front end was making a HTTP call, and it would go to this front-end app, and the reason we had a front-end app was because we had a REST API, but we didn't want to expose everything to the front-end app. So we had to have this intermediary in the DMZ that would allow us to interact with our backend. And the service layer would communicate to a database, and that would make its way back to the view, right? And the front-end app had, we had to do some third-party vendor stuff, so there was some mashup stuff that we had to do to make all this work. Okay, so I think this is really consistent with a lot of the problems that all of us deal with. We call a database through Unity Framework and Hibernate, what have you. We get some entity object back. We take that entity object, we turn it into a DTO object. We take that DTO object, that gets serialized to JSON, which could potentially go to another app, which takes in that DTO object and maybe creates a view model of it, or we create our own view model inside of our own app. And then that gets converted to JSON to get served up to hopefully something better than IE8. Right? Pretty straightforward. So this was my solution. This is the perfect solution for this kind of implementation. So you have your it's a trivial example. You have your people database. I dependency inject all the things. I have an iQueryable repository. I have a person repository that inherits from that. I have a model object. That model object binds to a DTO object. That DTO object gets converted to serialized to JSON. I can't serialize the person object directly because there's a friend object that's also a person, so you get this recursive serialization and Stack Overflow exception, so you can't do that. We hit another process boundary. The model binder comes in, picks up that object, becomes a person view model. I add the third-party vendor stuff to it. That gets serialized to JSON. That goes to JavaScript IE8. Pretty simple, right? This is how we effectively, build apps, right? So everything was fine and dandy. I was working on this website, and this is pretty much every piece of the app was built like this. And then I was put on a task to actually write some build automation. So they took me off the MVC application. I don't know why, and then they put me on build automation. So this is Rake. Rake is Ruby Make, and we were actually using Ruby Make to build our .NET applications. So back in the day, we were using something called Albacore. That's primarily what we use to do our build automation. So just real quick, I want to show you. We're gonna go through just pieces of this Ruby code. Okay, this is how you declare a variable. Yay! PWD stands for Process Working Directory. So parentheses are optional for function calls in Ruby, which is fine. Whatever. And there's some file util stuff to copy stuff. So basically, I built the MVC application. It goes to the output path, and then it deploys to inetpub www root. Real simple rake task. Okay. So of course, everything simple eventually becomes complex. And I was told that we actually QA wanted some situation where they wanted the output directory to map some convention. In this case, this was the date time plus some underscores. So here's the incremental progression that I saw in Ruby. And I was new to Ruby at this point in time. And here's how I refactor this code, right? So I create a dev output path, and then that returns the date, today, two strings it, and then does string replace for hyphens to underscores, right? But the interesting thing was, because I don't have to use parentheses on my method calls, the call sites stay the same. It's subtle. It was really subtle, and I didn't actually appreciate it for what it was at that point in time. So of course it gets more complex at this point. I would clean it. I ended up cleaning out some of the methods. So the replace directory call became a function there, and then call the replace directory right there. And then eventually they wanted to use the same build automation for another one of their MVC applications. So I don't want to copy and paste this method into two rake files, right? But there's not a lot of code here, so where do I go from there? And this is where I saw the next kind of incremental progression in Ruby. I can create a module. So a module, you can effectively think of that as a class with only static methods. But there you can include a line, you can say include build deploy, and it adds those methods as instance methods to the class and scope. So what I've done here is I've created the module in some other file. I do include build and deploy, and suddenly my output path and replace directory methods are there again. Okay? And it started clicking a little bit. So there's these constructs in Ruby that allows me to think about a problem very incrementally, and there's always a step towards a more complex solution that I can take when I feel like it. All right? And then finally, I had to introduce some state into the application. So I changed module to class. I created a constructor, which is initialize. So they wanted to change the character from underscore to, let's say, the letter T. And then instead of including, I initialize an instance of that class. Build deploy.new, and then I update the call sites. So I went from inline variables to a method, to a module, to a class. And that stepwise process was something I had to follow because I was new to Ruby, and it was really nice that I was able to take that approach, right? So back in the .NET world, I was tasked to create another endpoint that had this same problem structure that was for the original endpoint. In this case, it was colors, but there was something different about this one. It was significantly easier. The data model was easier. There was no circular references. There was no third-party vendor stuff. It was all just that. And I started with the perfect solution. Create the DB set, inherit, create the model, map it, DTO, JSON, view model, JSON, JavaScript. Because that's what you're supposed to do. There's no other way to do it. But looking at Ruby, I took a step back and I said, what's a good enough solution? How can I minimize the code that I'm writing to still provide exactly what I want at the end of the day, but with just less of this stuff? And here's what that good enough solution looks like. It's terrifying. So I have a repository that returns a dictionary of string object. It takes in SQL and sanitized parameters. Okay, you can't SQL inject this. And then my action result, basically dictionary to JSON. JSON.NET has a key value converter that takes dictionary values and converts it to JSON. And I just do repository.all, select asterisk from colors were named like 1, green. Inline, let's do it. And then in the website, I can do an HTTP GET on that. And I just reproject that information, adding an additional value, the RGB. So the idea here was that I didn't create the DTO, I didn't create the mapping, I didn't create any of that stuff. All I did was say, all right, get that data out, and then on the view side, instead of creating a view model, I just return a dictionary back to the front end and added another token there. Is this terrifying to anyone? You're like, yeah, kind of. And, it's terrifying, but at the same time, I was like, wow, I didn't bring in dependency injection. I didn't create 5 classes. I didn't do the serialization stuff. There's so much that I didn't have to do. that this almost felt, it's good enough. It's good enough for this project, for this specific task. So one thing I started to really get a little bit of heartburn about, it wasn't the inline SQL. That's perfectly okay. It was actually this construct here. That's a very verbose way to define a dictionary in C#. I can't think of a more concise way to do that, unfortunately. Okay, so I started looking at what other languages provided. So here's the C# version, right? In Ruby, that's how you can define. That's two ways you can define dictionaries. All right. So you can do name : which looks a lot like JavaScript, and this is another syntax for defining a dictionary. And then accessing a dictionary value is like that. In JavaScript, make sure to add the var, otherwise it becomes a wonderful global, and we all love that, right? But that's how you would define a dictionary in JavaScript. F#. So F#, there's a dictionary method, and you give it an array of tuples, and it creates a dictionary object out of that. Now the interesting thing in F# is that you actually use the dot operator for the brackets. So you do name dot open bracket, whatever. Closure is interesting too. The parentheses are on the wrong side, as you can tell, and the method invocation is also on the wrong side. But it's still pretty elegant, right? You define it, you give it the name, key value pair. Commas are optional in Closure, so they're just considered a white space, which is interesting. And then to access the value, you just say name for D. Okay. Scala is another language, and in Scala it's a map. They have another concept. Instead of doing colons in front of the name, they use an apostrophe. So apostrophe arrow Amir, and then that's how you access it. Objective-C will give you bloody stumps for fingers. So NS Dictionary *D equals @ so that's their literal. You have to put an @ sign in front of everything. So if you can't get something to compile on Objective-C, put an @ sign in front of it, and it might compile for you. So and same thing with classes. If there's something wrong, put an asterisk in front of the class name and a class variable name, and you might get it to compile. So there we have right there. There's Objective-C, and then we saw the C# version. I've just put it all in one line, and then of course we have to make fun of Java. So that's the Java version right there. Hashmap string object D new, hashmap string object. This syntax, this double curly syntax, actually creates a new class that implements hashmap, and then you invoke a method in there. So not only is this longer, it's also extremely inefficient because I'd be doing that every time. So it's pretty cool, right? So there you have it. So aside from Java and Objective-C, these are fairly elegant ways to create dictionary objects, right? And so I'm looking at this C# code, and I said, you know what? We have something like that. It's the anonymous type, kind of, right? So I turned the dictionary object to this anonymous type, but there's a gotcha with anonymous type. So when I try to serialize this thing, I got an exception. Does anyone know what that exception is? I heard a mumbling, so I'm going to assume that was the correct answer, and you're right. It's assembly internal visit to Newtonsoft, so anonymous types are actually defined internally. So you have to expose internal classes to whatever external libraries that are happening to use it. It wasn't bad. I was like, okay, I can put that in my assembly info CS, and there we go. Internal visible Newtonsoft JSON, things serialize. I'm a happy person. Okay, but now the situation came where the same projection that I did here needed to be used in two places. Okay, so I created my asViewModel method because I didn't want to create a class. I did the same projection there, and then elsewhere I tried to call asViewModel, and when I tried color.vm dot, all I got was object-related methods, right? Because anonymous types will only hydrate their properties within the scope of a method. So as soon as you extract that out to another method, you don't get that information there. So the solution was to make it dynamic. Nope, not going to do that. Not happening, not going to do that. Screw this, I'm done. I was so angry that I actually went back to WinForms. And I I took a bug. There was a bug that said, sort this thing. There was a list of people. Again, a trivial example, but it was to sort this thing. And the thing was, with this WinForms application, it was actually a 2.0 application that was upgraded to 3.5. So when you open it up, you're like, wow, it's just 2.0 used in 3.5, and there's no 3.5 constructs that are being used. So I pick a bug from the WinForms app, and I had this ordered adult people, and I wrote this, right? So the thing was like, it's not sorting correctly for some reason. This order by is not happening, and this was 2.0 code. So doing this in 2.0, that's an interview question that if you ever get it, you should leave, because that's a big red flag. They might be using 2.0. But this was basically what I rewrote it to. I said, well, okay, I need adults, age, order by p.age, then by p.split first, last, and toList. And I fixed it, and I checked it in. And around this time, this part is, again, this is kind of a true story. There was one of my colleagues that I was working with, and he didn't know much about 3.5. So when he saw this, he got pretty angry at me. Like I still remember it to this day. He was extremely, extremely frustrated with this code, to the point where he was almost yelling at me for saying, "What is this crap? What is this var crap? What is this backwards greater than equal to sign, because you got the greater than on the wrong side. I don't even know how this compiles. This is extremely frustrating." And that was a shock to me, because for me, I was seeing this guy. I was like, how can you not see this as something that could benefit you? If you just take the moment to learn this stuff. So I slept on it, cried a little bit, and I came back to the MVC stuff, and the dynamic thing that I was afraid of, it was the same. I was the same way my colleague was with 2.0 to 3.5. So, and I started looking around. URL route URL, that takes an anonymous type, but that's effectively dynamic. If you remove the O in controller, you're not going to get a compiler error for that. It's going to take it, and you're going to get a runtime exception, right? View bag, that's dynamic. SignalR hub, all that's dynamic, right? Nancy, this one-line program, this was the only program I could fit on one line. The underscore is dynamic. So, people were using this, So I started digging in. I said, okay, well, let me look at the source for ASP.NET MVC for this view bag, and I pulled down the source, and there's the view bag definition, and it uses dynamic view data inherits from dynamic object. So dynamic object is actually system.dynamic.dynamic object. It's part of the framework, right? So I at this point I was like, okay, there's got to be something built in that gives me what I want. So I Googled for dynamicobject.net, and I found Expando Object. I totally have to say it like that, because that sounds like the name of a superhero, a terrible superhero, Expando Object. But it was great, because it had the iDynamic meta object data provider. If you want to go into the bowels of dynamic object, implement that interface, and then after a week you'll probably have multiple personality disorder and kill yourself. But there's iDictionary, string object, a collection, IEnumerable, iNotify property change. It had all the things that I needed from a dynamic object. So I changed my repository. Instead of using dictionary string object, I returned dynamic. I'm doing this. And then my colors, instead of doing this projection, I could just say, well, okay, it's a dictionary of string object. I can take that IEnumerable of dynamic and just attach the property on there. Right? Just stick it on there as a property. And because this is a dictionary of string object, I don't have to do the internals visible to, because it serializes. Excellent. So that made me happy. And then I was sad again. And let me explain that part for you. All right. So here's what we have in Ruby. I was able to take a local to a method, right? And then when that method needed to be used in two places without state, I converted that to a module and then included it. Okay? And then when that module needed state, I converted that from a module to a class. There's this nice, elegant evolution of my code. And what really was unfortunate with C# was that I had this dictionary of string object, and I thought I was doing dynamic, but I wasn't. I was doing typeless objects. Okay, expando object is typeless. It's also sealed, so I can't inherit from it. Data sets and strongly typed data sets, that was a big problem with them, was that they were effectively typeless objects, and they fixed typeless objects with XML. Brilliant, right? Var sum object, new foobar, yeah, that's statically typed, but what's the type of var? It's typeless. It's a typeless object. And then some object dictionary is obviously typeless. And additionally, all this grip that I had on static typing was, coming loose. And what I found was that going from tables to the service, that was a process boundary where static typing couldn't save me from schema changes. You add a new column, you change the column name, suddenly things don't bind together and you get runtime exceptions, right? As soon as I go from a service boundary to another service boundary, that model binder that you have that's statically typed, that takes in that JSON payload, suddenly doesn't work because the JSON property changed. And then if you make it into IE8, nothing works in there, right? We already know that. But if it does work and your properties are wrong, you get that same issue. So there are all these process boundaries that existed that affected this dynamic approach. And on top of that, I couldn't see that same elegant transition into static typing like I saw with Ruby going from a local variable to a method to a module to a class. It just wasn't there. So from that came a need. And this has been a common theme with open source, is that a lot of the successful and good open source projects come from a need. And my need was, I have this dynamic productivity benefit that comes from being dynamic. I have the guarantees of static typing, but there's no way to transition from one to the other. And that was a chasm that I had to cross. And from that, I created Gemini. Okay, so here, this top part is part of that chasm. So I'm going to instantiate a new instance of Gemini. Gemini is effectively typeless, right? You can't ask a Gemini if it's a person. It'll say, no, I'm a Gemini. And I can tack methods onto it. Say hello, add that method on. Now, person can say hello. But now I can make this typeless Gemini object into a typed object. It's still dynamic, but it has a type. I inherit from Gemini, and now this say hello method becomes that. Okay, now here's the interesting thing about the DLR, is that you'll notice that this method is actually private, but I can still call it publicly. And on top of that, if I wanted to, I could stub it out. I could redefine it. And what it's going to do is going to call that redefinition. So suddenly I don't need a mocking framework, or I can defer the need of a mocking framework for later. So I create this dynamic object. It's got all these public methods that match this specific signature. And if I need to stub one of those methods out, okay, just redefine it to do whatever you want. Okay? It's all about the spectrum, right? I'm not saying you always want to do that. I find myself doing it a lot. But suddenly you've opened this other end of the spectrum, this productivity spectrum that you didn't have access to. And then eventually, it's like, okay, now I have this person object that's an actual type, and it's a dynamic type. So where can I go from there? Well, I can build onto this, because I can tack methods onto this thing. So this becomes my module approach in C#. I create a class that takes in a constructor, and then I tack on methods to it. There's my module. And then Gemini has a static method in there called person say hello to, and suddenly you extend that method, then all instances of person get that object. Any new initializations of person get that. That's trivial. Let's look at a way that I actually use this. So inside of our code, there were some database calls that were slow, right? The first hit, we wanted to take the initial hit, but we want to cache all subsequent calls. So here, I have a module called MemoWise, And what I did was I said, okay, what memoize does is says when I'm mixed in to an object, I'm going to look for a method called memoize that returns an IEnumerable. And for every function that returns, I'm going to memoize that function. I'm going to redefine it to where if I get a variant property, a set of properties in there, I'll give you the initial execution. Otherwise, I'll cache it. So here we have our slow person. I say hello. It takes 10 seconds for that to come back. But now if I use the same argument name, it returns immediately because it's cached that argument. And if I say hello with a different name, it takes the 10 seconds, and then after that, it returns immediately. So that's, I have yet to figure out a way to implement this as elegantly in static typing, okay? To be able to memoize a function like this. So something to think about. So next, my static brain went, this is an OO. There's no way in heck that's OO. And what I found, and this was another it's crazy that I get emotional about code, but this was another emotional moment for me. And a part of me was like, this is an OO, and it's like, well, yes it is. What C# had done to my brain was there was no difference between a class and an object. So I had to rethink about what an object meant. And what C# is a class-oriented programming language. They generate objects with classes. Let me show you an example. Ruby is an object-oriented language. Effectively, the class keyword is a factory for generating an object. So I want you to think about it from that perspective. I have class people def say hello. People define class. That's another way I can create a class by just executing methods. Okay? So a class is just a factory for generating objects. Right? And so what I did in C# was we have the static class, which is effectively just a factory for generating objects. And I created another way for you to generate a class. Okay? So once you start thinking about classes and objects that way, it pulls your brain apart from classes, which are a factory method, and then objects is what they generate. Okay? So with that, the final step to that path was, can I transition from a dynamically typed object to a statically typed object? So I have all this dynamic stuff, right? Dictionary to JSON. I have all this dynamic stuff. And here is my path to static typing. Okay, you can create a conversion operator and map both sides. And now I can explicitly cast any dynamic object that is typed still, it's dynamically typed, to a statically typed method, to a statically typed class, by defining those variants. So when it's time to go to a color DTO, I just cast that dynamic Gemini color object to a color DTO, and it just works. Okay? So now I can go from a good enough solution to a perfect solution, and anywhere in that spectrum. Okay? And that's really powerful. So just to kind of end this on this stuff. So if you install package Gemini, that'll give you the core dynamic construct. Install package Chamium. I'm actually going to show you that real quick right now. The website's there, Twitter. Link to the docs. This is where the slides are, and there's also a sample project in there that you can just clone down, run the console app, and you can play around with this thing. Okay. And then there's a lot of information on GitHub Amir Rajan /oak on the wiki for a deep dive into dynamic typing and how all that works. So to finalize this, I got all the way through the spectrum, but there was still this one issue. I was still having to inherit from this repository or initialize an instance of this repository. So I was wondering if I could push the other end of that spectrum, and I was able to. So iDynamic metadata provider. You're going to drop into parallels, use mirroring. Oh gosh.
Click yes.
Oh, it's like I wonder what happens if I click yes. So what I did was I created this type called dynamic DB. Okay. And so I create a schema. Blog has a title with a string. Comments has a message, foreign key to blog. right? Nothing up my sleeves. That's it. And when you initialize an instance to this dynamic DB, you set it up as dynamic. And if I want to insert a block, I just do db.blogs insert and give it an anonymous type. db.blogs does not exist on this object. It's using information schema to find the object and then creates an ADO.NET construct on the fly that can insert that repository, that value. db.comments, same thing. I can get a single blog entry, right? Again, these methods don't exist on DynamicDB. They're all using try get member or method missing construct inside of dynamic object. And then finally, which is really cool, I can do db blogs single.comments. Because of that convention that exists where the blog ID maps to the blog table, it uses information schema, says, okay, I know where the foreign key points to, I'm going to pull comments associated with that blog, and it generates the SQL to do that. And there are no classes, there's no methods in this thing. It's all done based on this convention of saying, okay, what exists here, what are the database columns? So you can do that, repos there, and pull that down. There you have it. Thank you.
We'll